Hello, and welcome to Hocking College Lab 1102. This is day 2 of week 7. We are 1 week away from the final exam, and I thought I would film outside today. I'm hoping the wind doesn't pick up and make too much noise against the microphone. All right, so today we are going to talk about chromatography. Chromatography is basically a separation technique. It's pretty common in a lot of analytical instruments anymore, some of the more advanced ones. Essentially, you've got two phases. You've got a stationary phase and some sort of mobile phase. And your solutes, your analyte, the thing or things you're trying to analyze is in both phases, as are other analytes or interferents. Um, they've got You've got different affinities. The solutes you're looking at will have different affinities to both phases. So as things are carried along by the mobile phase, they they spend more or less time in the stationary phase, and eventually it separates them. Let me pause for a moment, and I'll get my example. Okay. So as an example, I've got some pieces of paper. This happens to be some oversized tea bags we have. I've put a line on them. This one was with a red Sharpie, and then I dipped it so the end was suspended in a isopropyl alcohol solution, something around 50%. So as that moved up, it would act as the mobile phase. The paper is the stationary phase, and the ink is my sample. And so you can see we've got red coming up through here, and then way up here we've got this line of yellow. So some of the components in the ink separated depending on how fast they moved through the paper and affinities with the paper and the alcohol solution. Um, let's see. So you can have things like this happen. This was a green Crayola washable marker. It just carried everything all at once. Purple Sharpie didn't show much. Blue Sharpie didn't show much. There's this one used red Sharpie on a paper towel instead. So you can see the what the solid phase is. Makes a difference. This one was purple Sharpie. You can see we've got a band where it's purple and a band where it's red. We've got some separation starting to happen. The other thing that's happening there is the bands are getting wider as it goes along. There's a better example of that. We've got the purple band and the red band. And that. Um, wait a minute to get those so I still have them for class tonight so they don't blow away. Okay, so there's a few different ways to identify chromatography techniques. Um, a lot of the most common ones tend to be named for the liquid phase. So you've got gas chromatography and high performance liquid chromatography that we'll talk about in a little bit more detail. You can also have planar and column chromatography. They can be categorized by the shape of the immobile phase. These strips would probably be an example of planar chromatography. It's a plane shape. Most analytical instruments tend to use a column shape. It looks like a tube that's wound in around itself. You can also have name them according to the interaction with the stationary phase. So you've got absorption, partition, ion exchange, size exclusion types of chromatography. Um, so column chromatography, essentially you've got a tube with the solid that contains the solid phase. You put your sample in it. Things interact differently with the sample, with the solid phase and the liquid phase, and they start separating, as you can see in the picture here. And then as it comes through the column, so you've got a mobile phase that's constantly flowing, and it carries things down, and things get held onto the sample phase, and that delays them. And depending on how attracted they are to the stationary phase, sorry, I keep saying sample phase, how attracted they are to the stationary phase, they slow down or not. And then they come off the bottom of the column or the end of the column at different times, and you can collect them differently. If we were to somehow measure the signal at these different points in the column during measurement, we would see something like this. You'd see we've got an overall, everything's mixed together, and you start seeing a little bit of separation, and by the end you've got a good separation. So column length is one of the things that we can adjust in this type of separation. So GC is a very common instrument in an analytical laboratory. You've got some sort of gaseous mobile phase. It needs to be an inert phase. Usually it's something like helium or nitrogen or argon. Um, your sample is usually a liquid or a gas. It gets injected the uh, into the instrument. Gets If it's not a gas already, it gets evaporated in the injector. So the injector is a little heated portion. Um, After that, it goes into the column. The column sits inside an oven. As you can see here, this little ring around the fan is the column. This one happens to be a capillary column. We'll talk about that in a moment. Um, you've got temperature control on the oven, so you can run it at whatever temperature you want, or run it at one temperature for a while, and then increase the temperature to change the behavior of your sample with respect to the phases. And sometimes that needs to happen to you know maybe one component will stay on the column, so you run it at a lower temperature till your first separation is done, then increase the temperature to push the next bit off the column. Something like that. That can happen. It can be fairly common. Um, Columns in general come in two broad types. You've got a packed column where your tube, they usually look like they're about an eighth of an inch outside diameter, stainless steel tube. Usually it's full of some sort of particles of your stationary phase. You've also got capillary columns. They're very, very tiny things. So we're talking 64ths of an inch or smaller. Um, they're very, very small. Um, Generally, it's open. The inner wall of the tube is coated with something. As you can see in the slide, it's either a you know complete liquid coating, porous solids coating it, solids coated with liquid. There's a few varieties depending on what behavior you want. Then as things come off, so you can see what you've got, you have it run through some sort of detector, so you get your first bit of analyte through. It interacts with the detector and gives you a signal. Signal goes away. If you've got good separation, then the next bit comes, interacts with your detector. You get a signal, then so on. There are different types of detectors depending on what you are looking for. They interact differently with different chemicals, so you can adjust your measurements, your sensitivity and whatnot by changing what detector you have. Thermal conductivity is a fairly basic one. With some GCs, at least, it tends to be the default that comes bundled with them. Gas flows across a heated wire and changes the thermal conductivity of the wire. You get a measurement of that. You've got flame ionization detectors that there's literally a flame there, and as the gas flows across it, it changes some of the flame behaviors electrically, and you get a signal based on that. A GCMS, GC mass spectrometer, tends to be a fairly common. You get your analyte comes off, gets broken down, and you get an idea of some of the chemical structures in it based on that. There's a lot more information on all of this in the textbook, and imagine you will be going more into all of this during your instrumentation courses. So I would encourage you to look through the textbook and become a little more familiar with more of the depth as well. I'm just trying to make sure you've got an overview, some of the concepts of what's happening before you get too into the details. Then we have high performance liquid chromatography. Um, you've got a liquid sample. It's the mobile phase is a liquid. There's a pump required in the instrument. Usually the pressures involved are fairly high. I'm afraid I don't remember the actual pressure ranges anymore. The columns tend to be pretty short. It's straight, so they're 8 to 12 inches long, I think. Most of the ones I've seen, and a little bit bigger around. And usually you've got some sort of short little guard column in front of it to help clean things up before it hits your analytical column. So it's usually it's the same packing as your analytical column, and it's short enough not to really provide any separation, and it acts as a sacrificial layer, so any contaminants interact with that, and before it gets to your more expensive, larger analytical column that's going to do the separation you need for your signal. Okay, that is what I had on chromatography. And hopefully I will see most of you this evening. Thank you. And